kind of a more detailed analysis of the earthquake locations in the following days of those earthquakes. So we're looking here at the first two days of events with the magnitude 6 and larger earthquakes through there. And the closest, the largest events are about 4 kilometres off Brighton Pier, New Brighton Pier there. And they cluster a lot. They cluster with a northeast southwest orientation. As you, further on into the January 2nd sequence, you can see as this sequence here is the primary sequence that was felt in the January 1st, 2nd time period, and that is at the northeastern end of this cluster through here. So if we move through to this figure here, that's just looking at the first few days of events again. And what we can do is we can look at each earthquake individually and determine what actually occurred during that earthquake and what kind of slip occurred, at what depth, and the type of fault that rupture occurred on. And what we can say is the three of the largest earthquakes in the first 2 days occurred on a kind of a thruster, reverse or thrust fault. You can see it here on the right, and with this kind of a steep dip, dipping towards the south, dipping towards the southeast, and the three events here probably didn't necessarily occur on the same fault, which would be about 9 kilometres long if it was the single fault, but probably occurred on subparallel faults, all with the same kind of orientation and all with the same dip. And they each of in the first few hours, each event would trigger the following event with the transfer of stress at the end of each fault. So we're looking at a similar. All of these earthquakes occurred in a similar manner, and implying that there's the pre-existing structure in the basement of this area has an existing fault structure. So what we have here are the peak ground accelerations recorded across the Christchurch city for going back to the February 22nd earthquake, June 13th earthquake here, and the December 23rd events, the 5.8 and the 6. And as you see, on the February 22nd event, which was with the rather complex fault structure that occurred, which was ruptured in that event, you have peak ground accelerations of more than 2G in some locations like Heathcote Valley, and certainly very high vertical accelerations. The red is the vertical acceleration, the blue is the horizontal accelerations. Certainly very high accelerations, both vertically and horizontally across the city. As you move through to June 13th, which occurred slightly off the coastline through here, in a more north-south orientation, then you still got the high horizontal accelerations on the coastal stations through here, and lower accelerations in the central city. And then finally, as you move to the current events in the December sequence, then you have much lower accelerations again right throughout the central city compared to for example, the February 22nd event. And you've only got a few stations, but Heathcote Valley, for example, still has fairly high horizontal accelerations, and a few isolated stations, for example, near New Brighton, with a vertical acceleration there of touching 1G on the December 23rd. But otherwise, quite low, much lower accelerations than observed in the earlier earthquakes as the earthquakes migrate offshore. Having said that, you still, in some of the larger 5.5 plus earthquakes, aftershocks are occurring, you're still seeing around 20% G, or 15 to 20% G on some of those events. on stations like South Estuary here. At this point, I think that's all.
Now, these are the these are the December, early January sequence, plotted in the wider region in terms of what we know about these active faults of the region and the older fault structure as well. One of the important things is to think about these earthquakes occurring at 8 and 10 kilometres depth. That means then they're down in the very old rock of New Zealand, the same as the rock that you see up at Arthur's Pass, etc., etc. It's suffered a lot. It's more than 100 million years old, and it's had a pretty difficult life. So it's broken up into all sorts of different faults, and that's where most of these earthquakes are happening. We can, and I'll show you next, some work that our colleagues in Niwa did, supported by some of our research from the Ministry of Science and Innovation and also from the Earthquake Commission, offshore here to try and look at the depth section of these fault lines to understand what's occurring at what depths and put these into a sort of a depth context as well, just a spatial context. So, the Niwa guys, when they were offshore, found a little bit of an extension of the February 22nd fault, extending offshore a little bit more faulting down here, and they newly discovered, compared with their previous work, which is this thing through here, which has been given a name, the Kaiapoi fault. These earthquakes are reaching up towards that now, but they are not on that fault yet. They may migrate to that fault, they may not migrate to that fault, but they're not there yet. These are, as Stephen was saying, probably represents a fault line going through there, something like that. It may have reached up to about 1 kilometre below the ground surface, and therefore we can look at this depth section to think about, well, have we missed something, can we see something in these depth sections to see if we can understand more about this feature now that we've got the wisdom from having had the earthquake. We know that the faults up in the north part here, those move their average movement rate, and of course they're not slipping all the time, they are locked up, and then once in a very, very long time they do break in a significant earthquake. These are about 10 times faster than that. That's very much faster than anything associated with anything we can see here related to these December events. So there's quite a migration in the activity rate from North Canterbury down into southern Pegasus Bay. Everything we've learned since September reinforces that view that everything we're seeing in the Christchurch local area are very, very rare events. All of the work that we do continues to come back and reinforces that same thing. It's very, very much the wrong place, wrong time for Christchurch City in the 21st century. So next I'm going to go to a depth section here to try and give you some idea about how these things might look at if we try and look down, image down through several kilometres.
Can you explain what you mean by faster?
Faster means the movement rates of the fault. The average movement rate. So if a fault moves, well, we can see some of these things in some of these sections here. For example, we see layers. These are shot with something like the same technology that's used for looking for oil. By doing marine seismic surveys, they can see down here, that's looking down about 3 kilometres down into the crust of the earth, below out to sea here, and it can see different reflections, different layers. It sees different layers in the geology. So when we look at these layers, we can work out what age they are, and we can work out how much there's some displacement on those. So in here, this one is this displacement back here, and we can track those things through these sections, and therefore we can see at what stage did this fault line move. It's moved more recently than the rock layers. So that can tell us some of the very long-term history on the movement on some of these faults. And when we get up into these colour-coded here, this stuff down through here is the greywacke bedrock that makes up most of New Zealand. Okay? This is the stuff that's more than 100 million years old. It's down here under the sea at about 3 kilometres. Younger layers in here, this one, is the volcanic layer coming off the Banks Peninsula volcanoes. That's around 6 to 9 million years old. That's got displacement in here of maybe 100 metres or so of one of the faults in northern Pegasus Bay, which is quite active. It's got a movement rate of a few hundred metres over 6 million years. The Alpine Fault, for example, has a movement rate about that much displacement over a few thousand years. This is over a few million years. So these are different rates of movement on these fault lines. They give us a long-term picture. The most recent earthquakes we've been having maybe come up to about a kilometre below ground surface, and so this is this Kaiapoi fault here, a bit further north than where we were seeing the recent earthquakes. That's got some indication of some very small movement of the 6 to 9 million year old volcanic rocks. It's got no expression higher up into the sequence. Well, it's got some expression up to a bit higher in the sequence. Our most recent earthquakes were occurring in this section here, and you can see that all of the layers go through here very, very smoothly. If there is a fault in there, it's got tiny, tiny amounts of movement because it can't be detected with the resolution we can get out of this, which is pretty good. It would see a few metres of movement. So the earthquake we've just had off there is not a very frequently repeated one, otherwise we would see disruption of some of these layers. So very rare event. The other thing here is that the earthquakes, the aftershocks we're having, are down at sort of 8 kilometres depth. Now if this is 3 kilometres, if we could extend the section, we'd be down here at 8 kilometres, and you can see how much more faulting there is in these old rocks. It's been through a really hard life, so once you've had an earthquake, then the earthquakes are going to settle down and release stresses across many of these small faults probably. So that's why there's a sequence of earthquakes will occur after the big earthquake as you redistribute the stresses that have been caused by that earthquake. So those are very expectable. They're occurring way down here at about 8 kilometres depth. Only the very biggest of the earthquakes would rupture all the way up through here, and that tells us more about these magnitude 7s than 6s. Okay, so I think that's really the context here. This line goes across where the December earthquakes were occurring. We can't see anything. So we can only say that the events that we have been having are very rare events. Where the next ones are going to be, well, that's an obvious question. Don't really know. The tendency is to migrate towards the east. We don't think there's a big fault out there directly to the east. They may go to the north, they may go back down to the western end, or sooner or later they will stop. So I think that's really what we can come back to some of those if we want to answer some more detail, but I think we're go to it.